Hello and welcome to the Sleep Science Podcast. I'm Penny Lewis, a neuroscientist specializing in sleep and memory and the presenter of this show. In the podcast, we talk about all things related to sleep, from dreaming and sleepwalking to what sleep does for our brain and body and how we can get more out of our sleep. Hello everybody. Today we're extremely lucky to have Dr. Francesca Siclari with us. She's a neurologist, she's an expert in sleep, and she has a particular interest in parasomnias like sleepwalking, as well as an interest in dreams. Francesca is a research group leader at the Netherlands Institute for Neuroscience, and I think we're going to have a really interesting discussion. So Francesca, welcome to the show.
Thank you. Thanks for having me.
It's really great to have you here. I have lots of questions for you. I was having a look at some of your work. And the first thing that I wanted to ask you about is your recent work on parasomnias. So you have this really exciting paper. And I wondered if you would start by telling us what parasomnias are.
Yes, of course. So the term parasomnia comes from the Greek and means a long sleep, basically, and refers to abnormal behaviors or experiences that occur during sleep. And there are different types of parasomnias that occur in different stages of sleep. And the ones I was particularly interested in the study you refer to are non-REM parasomnias, so parasomnias that occur mainly actually in deep sleep. And there's a group of parasomnias that occurs in this stage that is called arousal disorders. And that comprises sleepwalking, so people who basically have an incomplete awakening out of deep sleep and then start to walk around. But also sleep terrors, when there are bigger manifestations of fear, so screaming and having a frightened facial expression. And also confusion arousals, that's when a person just has this partial awakening during deep sleep and appears confused.
Oh, wow. So it's actually lots of different kinds of parasomnias. But the one that you focused on in this paper was more the sleepwalking, is that right?
Well, actually, these three types of parasomnias, they occur often in the same individual. And the boundaries are really fluid, actually, between the different types. So in this study, we included mostly patients with sleepwalking or sleep terror, but many of them had both.
So this is something that I get asked about a lot, and I never have the information to give the right answer. So I'm just going to ask a little more here. Can you explain the difference? Sleep terror, is that the same as night terrors?
Yes, absolutely.
What actually is involved in that?
During a night terror, basically a person appears to be waking up during deep sleep and starts to appear very scared. So basically there can be screaming involved, frightened facial expressions. They can also leave the bed. They appear to be in great distress. And when you look at the brain waves during sleep terror, those people, although they appear awake, actually have sleep waves in their recordings. So they are still asleep in a way. It's a hybrid state between wakefulness and sleep. It's very common in children, like all non-REM parasomnias. So many children, up to 10%, have actually one type of non-REM parasomnia. And then usually it goes away with age. But in some people, it can even persist into adulthood or even occur for the first time while being an adult.
And when you say they still have sleep waves, do you mean slow waves? So is it non-REM sleep?
Yes, slow waves. Yes, that are typical of non-REM sleep. There have been studies of non-REM parasomnias that have captured episodes while patients actually had electrodes in their brain. Those were epileptic patients that did these recordings for other reasons, but the researchers happened to capture episodes of parasomnia, of non-REM parasomnia, and they found actually that these people technically were both asleep and awake. So some areas of the brain showed patterns of wakefulness as if they were awake, and other areas of the brain showed the brainwaves that are typical of deep sleep. So it's hybrid state, actually.
And do we know what causes it?
So definitely in children, maturational factors enter into play. We also know that it runs in families. So if you have someone in your family who is sleepwalking, for instance, you have a higher chance to sleepwalk. We haven't fully identified the genes that are involved in this condition. And then actually it's conceptualized usually as something that occurs when a series of factors that are called precipitating factors make your brain really want to stay asleep. Like for instance, if you have not slept well or not slept enough for many days in a row, then when you eventually go to sleep, then if you have this predisposition, then a sleepwalking episode is more likely to happen because your brain really wants to stay asleep. And then when at the same time there are factors that want to wake up your brain, like noise, sudden noises, or even stress, then the brain gets itself into a mode where on the one hand it wants to stay asleep, and on the other hand it wants to wake up. And that's when these episodes occur, where the brain basically gets stuck between sleep and wakefulness. That's how it's usually conceptualized.
It's so interesting. And it's so interesting that it also tends to happen more in kids. I mean, I know you say it's developmental, so maybe their brains haven't figured out that balance between sleep and wake so much.
Absolutely, that's what the idea is. It also goes perhaps with the observations that sometimes kids can be extremely difficult to wake up completely, depending on when you wake them up. So there might be a natural resistance to complete awakenings.
Yeah. And does all of what you've said now is kind of true for all parasomnia? So because we started talking about night terrors, but actually the balance between sleep and wake and the fact that it's more prevalent in young children, this is true for all of the kinds of parasomnias that you mentioned, right?
For these non-REM parasomnias, yes. For arousal disorders, absolutely.
Yeah. So I'm just going to ask a little bit more kind of general questions on this because there's so much interesting stuff here. I've read things about people actually committing crimes in their sleep. You know, there are these kind of court cases from the past where someone got up and drove 30 miles and I think killed his wife, and you're nodding, so I know that these are familiar to you. Other people have killed bed partners. So there have been crimes, for instance. There are also things like night eating where people go to the fridge and they eat copious amounts, but this is all in their sleep, they're not aware of it. Are these different than the other arousal parasomnias, or is it part of the same thing?
No, so violence and eating can occur within these non-REM parasomnias. There's a whole range of behaviors that can occur. Fortunately, violent behaviors are rare, but they can occur. And obviously, when this happens, this is terribly dramatic because those people are obviously in an altered state of consciousness, cannot be made responsible for their actions. And it's also very difficult in a legal setting to determine whether someone had a parasomnia episode retrospectively, and also whether a person actually is a sleepwalker or not, because there are many sleepwalkers that don't display any episodes for months and months and months, and we don't have a very clear marker to say, okay, this person is a sleepwalker, as opposed to someone who pretends to be one. So there's a big legal complexity involved in these cases of violent behavior, which fortunately are rare. But whenever I see a patient in the sleep clinic, I really make them aware of this possibility, and we discuss what can be done actually to prevent the violence in this context.
And what can be done?
Well, we try and prevent the consequences of the violence or the occurrence of parasomnia episodes. Typically, having a very regular sleep schedule is something that we advise people to do, not to be sleep deprived. Also sleep in a calm environment without noises, without disturbance. Sometimes we use videos in patients, home videos, to see what they actually do during the night. And I was surprised to see that sometimes episodes can be provoked by pets, just a cat jumping on the bed at the right moment or things like that. So obviously having a bedroom environment that is free of such disturbances is important. We advise people not to sleep on high beds because sometimes they can fall down, injure themselves during the episodes. Remove any dangerous objects or furniture from the bed environment. For example, in the United States, it's also weapons are an issue. Some people have weapons near the bed. Also, in some cultures, it's a common thing to have the door open, also the front door of the house. And some children actually have died because they just ventured outside in a sleepwalking state. So these are like common sense measures that need to be taken to reduce the risk of injury during these episodes.
I mean, it's really scary, actually. And I guess because these parasomnias are more common in children, it's not uncommon that a child would get up and walk around. So surely having the doors closed is an obvious thing you could do.
Or the windows also. I have had cases of patients where they jumped out of the window. That is also, they can be really dramatic. Fortunately, as I said, it's rare, but it's better that patients are informed.
Yeah. And I mean, of course, it's interesting. Now we're just kind of thinking about it, what's involved here, and it's interesting to hear about these things. So is there any explanation for why a simple thing like, getting up and walking or talking would turn into a violent behavior. Do we have any idea why that would happen? Is it perhaps linked to a dream, or do we just not know?
Okay, that's interesting. So that partially relates also to the reason that I started studying this phenomenon more in detail. What I actually wanted to know is what a sleepwalker, what they experience actually during their episodes. And while interviewing a lot of them, it became clear that violence can occur in a variety of instances. For example, sometimes they can reflexively hit another person that is approaching because they are sometimes in a state where they misinterpret reality. So a bad partner is actually interpreted as being someone else, and often their experiences or these misinterpretations have a bit of a negative connotation, and suddenly it becomes someone who's dangerous and who wants to harm them, and then they defend themselves. Sometimes this can also happen reflexively without them wanting it or having actually the intention, because the state of consciousness is actually quite variable. In some cases, there appears to be very little experience associated with their behaviors, as if they were a bit in automatic mode, and at other times, they really have an intention in mind that is often related to something that appears like a dream scenario. So violence can occur in these cases, and sometimes simply injury can occur because they interact with things that are not there. For instance, they might lean on something and then lose their balance and fall because in their dream they're leaning on something that they perceive but that is not there in reality. Or, for instance, I had a patient who was convinced that he was at work and he was sleeping under a pitched roof, and then he was actually getting up and hit his head against the pitched roof because in his head he was at work. He wasn't in his bed sleeping. And so, yes, this is a bit the context where injuries can occur.
And so it sounds like you've been working with these patients for some time, and through seeing multiple cases and multiple things that happened, it made you, would it be correct to say that it made you start to wonder what's driving this, where it's coming from, and that's what's caused you to do some of the experiments that you've done?
Yes, absolutely. That was one reason. And then the other reason is that I had heard that often patients actually acted during these episodes according to a dream scenario. And I'm also very much interested in dreams. And usually a dreaming person doesn't reveal anything about their dream in real time, right? If a person looking at you dreaming doesn't see anything of that dream unless you record the brainwaves, and even then you don't really see the content of the dreams. And parasomnias, by definition, actually have visible behaviors, and I was very interested in relating this behavior to actually the experience of the person. And I wanted to know, okay, is this behavior always a reflection of a dream going on, as was suggested by some? Or can this behavior sometimes truly occur without any experience at all, in a purely automatic mode? And how complex can it be? I thought the best way to really know is to ask patients, retrospectively, but especially to record these episodes in the lab. And as soon as the episode is over, just talk to the person, because yes, these episodes, we also know they're very easily forgotten, like dreams. And so I really wanted to have the chance with my team to interview them directly after the episode and ask them, okay, what did you just experience, if anything? And also we wanted to know, can we see something in their brain activity, in their brain waves? Does this look like dreaming, or does this look like other patterns? These were the questions we were interested in.
There's such interesting questions and really kind of wide open, I think, until your work. I mean, there hasn't been much on these kind of questions, right? Tell me a bit about the experiments that you then chose to do, because I know it's been a series of experiments.
Sure. So the first thing I actually did, and that was when I saw these patients in my consultation, is to set aside some time, about 2 hours, and really ask many questions about their experience. So that's what they remember just over a lifetime. And by doing that, it became apparent that the level of consciousness actually appeared to be variable in non-REM parasomnia episodes. There were some patients telling me, I never know what I'm doing actually when I'm doing it. And when someone wakes me up after it, I don't have the impression that I experienced anything. And then there were examples of patients telling me a very elaborate dream, and that their actions during the episode reflected what was going on in the dream. So I saw that there was a certain variability. And another thing I discussed with them in these interviews is, do they actually perceive their environment? Do they see or not? And there again, their answers suggested that it's variable. There were patients that could easily interact with others during the episode. They could have conversations, that could avoid obstacles, they could seek out really specific objects in a location. For instance, I had a patient who had an episode where he dreamt that his dog was dying of thirst. A dog, it wasn't even his dog. And so he went to the kitchen and he got a little bowl, filled it with water and put it next to the bed. And the detail that I love is that he didn't want the water to splash on the floor, and so he put a little towel under the bowl. So you see very intentional actions where they are connected to their environment. And then there are cases where basically everything, the whole environment is hallucinated. So they move actually through fully imagined environments. It can be their workplace, as in the example before. It can be a volcanic landscape. It can be a jungle, whatever, that really has nothing to do with the real environment. And then that's where they also get hurt, because they are functionally blind, actually. They bump into objects because they don't see them, they see something else. And so there's a whole range, actually, of sensory disconnection. So sometimes they're connected to the real environment, and sometimes they're connected to an imaginary environment. And sometimes there's something in between where they, in some rudimentary form, I think, perceive the environment, but they misinterpret it. So they can know that a person is there, but they don't recognize this person as their bed partner or their wife, but they think it's someone else. Or they take an object for another. They might just carry a plate, but think this is a cactus or a plant or something else. So there's a whole spectrum of how connected they are actually to the environment.
And is that, again, explained by just the fact that parts of their brain will be in different states? So, and that could be different in every case, in every person, like exactly the mixture of which parts of the brain are awake and asleep and in other states of consciousness.
That was the next question I had. I knew it was variable, but what determines this variability? And that's why we invited these patients over to the sleep lab to actually record their brain activity and see if any pattern could explain these differences. And so what we did, it was quite a tiring protocol for everyone. These patients came to the sleep lab, and then we just recorded them a night with high-density EEG, so EEG recordings that record the electrical activity of the brain. We used many, many electrodes to really cover all the brain areas, 256, so we call this high-density EEG. So the patients slept with this EEG net, and they had a really long cable which allowed them to move around in the room, so they could sleepwalk if they needed to. And the first night we just observed them, and some of the patients presented episodes, and after the episodes we would immediately interview them through intercom. We were sitting in another room, we could see the video, we filmed them, and then we would ask them through intercom, what did you just experience? Or what was going through your mind was the exact questions. And then after this night, we had actually another night in the lab where they weren't hooked up and they were not allowed to sleep. So we really wanted to mimic a bit the situation that favors these episodes. And so we wanted to increase the sleep pressure by keeping them awake and only letting them go to sleep the next morning. And then when they entered a deep sleep, so a slow wave sleep, that's when most of the episodes happen, we would play very strong, arousing sounds, actually. In some cases, this induced the episodes, and then again, we would interview actually the patients about their experiences.
So what kind of sounds, strong arousing sounds, you mean like unpleasant sounds or just loud sounds?
It's like a very loud beep, and it's quite strong. And yes, in some cases, the patients woke up just normally, just a normal awakening. In some cases, they presented an episode, and that's when we interviewed them about their experiences. Several observations we made that I found interesting. So the first observation was that indeed, whether you will experience something or not during an episode depends on how activated your brain is. When we played a sound, when parts of the cortex, so the outer part of the brain, were active, and particularly the parts involved in dreaming, that we had seen in another study to be involved in dreaming, then patients were more likely actually to report a dream, as if the brain was in a state where it could create a dream. And whereas when there were, the more slow waves there were, so the more sleep-like the activity was in the entirety of the brain, the less likely it was that they experienced something. So we saw a relation actually between the degree of activation of the brain and the experience, the presence of experience, actually, of conscious experience.
How do you measure activation? You're talking about particular frequencies of activity, or?
Yes, so we chose the very low frequencies and the very high frequencies. Obviously, this is something we do once the data acquisition is finished. And basically, we look at the low frequencies that are more sleep-like and the high frequencies that are more wake-like. I'm simplifying a bit here. And then we compare basically the instances where patients reported an experience and the instances where patients did not report any experience. So when they were doing things, and afterwards when we asked them about it, they said, there was nothing, basically. There was nothing in my mind.
So they don't remember doing anything, basically.
Well, they have 3 different possible answers. I was experiencing something, and then can relate the content. The option of saying, well, there was something, but I don't remember what. I don't remember any content. And the option, I have the impression there was absolutely nothing. And that was actually the minority of cases. Only about 20% of cases, participants reported this option. And when we looked at the brain activations between the presence of experience and the no experience were different than when we compared the brain activity associated with the recalled experience and the ones where they did not remember the content, but they had the impression that they had experienced something. So to me, it suggests that obviously this is debatable, but I truly have the impression that in some cases there's no experience. And those were very short episodes, quite stereotyped, quite similar, while in the longer ones that were more complex, most of the time they experienced something and could remember it. We interpret it to be 3 different scenarios: forgotten experience, but also possibly behaviors without any experience at all, actually.
So when you say short and long, what kind of duration are we talking about? Are we talking about like 1 minute versus 5 minutes, or?
No, it's more in seconds. So a short one would be 5 seconds, very short, like could be a short scream or looking around or just appearing very perplexed or saying things. And the longer one then would be 20 seconds. That was our average actually, or 25. But in the lab, we didn't have any episodes that were much longer than that.
And when you talk about the low frequency and the high frequency, so I mean, some of our audience will know about the different frequencies. So I think by low frequency, you mean like slow waves?
Yes, so elements that are typical of slow wave sleep actually, absolutely.
Yeah, and high frequency, do you mean gamma or?
Well, there were so many movement artifacts that we couldn't go up to gamma, so we used beta instead.
Okay, and so did I understand correctly that for the episodes where they reported that they knew they were doing something, they had some kind of a mentation or dream or awareness, they had a higher beta.
High frequencies and low frequencies, yes.
So it's the ratio between them, is it? So they had a higher ratio between high to low frequencies. And if they weren't aware of anything, they had the opposite. So they had the higher low frequency. Yeah.
Exactly. It's not exactly the ratio, but both. We found both lower frequencies and high frequencies when they had an experience.
And so how do you interpret that?
Well, we know that the very low frequencies in the brain activity, they represent so-called slow waves. And we also know that during slow waves, the thalamocortical neurons in the brain, they become silent before showing activity again, become silent. They go into this on-off rhythm. And it's possible that when a big part of the brain actually shows these silences, that this could actually interrupt the exchange of information across different brain regions. And that is thought to be, at least from a theoretical perspective, a main prerequisite of consciousness. So different parts of the brain can only communicate when there's no silence that interrupts them.
So it's kind of like bytes are being taken out every time you have a trough in one of these big slow oscillations, and those bytes I guess what you're suggesting is that might be enough for you just not to have any consciousness at all.
Yeah, the more they are, the more widespread they are across the brain, then the less likely it is, I think, that the patients have a conscious experience. We also found that it matters where they are in the brain. And we found that if they are more in the posterior regions, especially the visual areas, then they will describe fewer conscious experiences.
And how about the higher frequency activity? Does it matter where that is?
Similar, exactly.
So again, if it's higher frequencies in the kind of visual areas, then they're more likely to. And when people describe experiences, how do they describe them? Is it often a kind of a visual thing, or is it just say, I knew that I was doing this, or I was in this situation, or is it, what do they say?
Yeah, so in about 80%, these experiences were about something that was going to happen, something mostly negative. For instance, we had a patient who had a 6-month-old baby at home. That was the reality. And during the episode, we saw him actually getting up and looking through the bed sheets, looking under the bed and screaming for help. And then when we asked him, what did you just experience? He said, well, I was looking for my baby, my little one. I thought she had fallen off the bed and I couldn't find her and I screamed for help. So exactly what we actually saw. So often about an impending danger, basically. Another patient, we saw her getting up in the bed and reaching actually towards the wall, touching the wall and saying, no, don't die, please. And then she told us that she was actually trying to save ladybugs from falling and from dying. So often there was the idea that something was going to happen. And another interesting observation in this context is that we played these really loud sounds to provoke the episodes. And in only very few cases, I think it was 11%, the sound actually figured in the report. Most of the time, they had the impression that something dangerous was happening, but it had nothing to do with the sound, actually. I found this very interesting because it actually suggests that your brain during this state, or even during sleep perhaps, is more sensitive to the meaning of the sound, or the potential danger associated to the sound, than to the actual auditory content. Because most dreams, and that relates to your question, were actually visual. Most of the time they had more the visual hallucinations than the auditory ones. So the sound just didn't figure anywhere.
It's so interesting. Do you think it's partly because the sound you chose, I mean, I know it was loud and annoying, but it wasn't kind of a meaningful sound. It was just a beep. Do you think it might have been different if you had chosen a meaningful negative sound, like a scream or, I don't know, a dog growling or...
Possibly. It would be interesting. It would be absolutely interesting to try that. But perhaps it's really the brain in this state just makes the difference between dangerous potentially or not. And then in this case, I think elaborated on the danger. But it would be a very interesting experiment, I think, to do.
So there is a kind of an older theory, I think, about K-complexes, which are basically if you play a sound during deep, slow wave sleep, there are these huge oscillation responses to the sound. And as I remember, there is this theory that K-complexes are the brain kind of being aroused by the sound, checking whether it's a dangerous thing, and then deciding that it's okay and going back into a deep sleep. Does this kind of fit with or relate to your findings, you think?
We actually saw that when they experienced something, we saw more of these K-complexes just before, whether we gave a sound or not. So that's also interesting. I don't know if that's the function of K-complex. So we definitely saw a K-complex-like presence before the episodes when they reported something.
Yeah, okay. I mean, it's very hard to know what those are really doing. I thought I saw a parallel there, but maybe it's going too far.
Yeah, I wouldn't know if that's exactly the function of K-complex. I couldn't say, but we saw K-complexes associated, with these episodes. What also was interesting is that even when we didn't play any sound, sometimes in the spontaneous episodes, the patients had the impression that someone had just talked to them or that there had been sound. The episode would start like, huh? What did you say? Or like the startled reaction a little bit. So whatever we do with the sound, I think it mimics very well what happens spontaneously, even if we don't play any sound and the episodes happen.
Yeah, but you're just using the sounds to kind of bring the episodes on in the lab condition.
Exactly.
Now, I know that you've done a lot of work on dreams as well, and you said at the beginning that part of your motivation for this work was to kind of look at the relation between the parasomnias and the dreams. Would you consider these, can I call them mentations that they were having, that they're reporting, would you consider these dreams? And how does this tie in to the work that you have done on dreams?
Yeah, so if we look at the phenomenology, I think they can be considered dreams. So all the core features of dreams are there in these experiences that the participants describe. In their full-fledged expression, we have the hallucinatory character with mainly visual hallucinations, but also auditory ones. Just like in dreams, we have false ideas. So basically, during the episode, the person believes in a different reality, not in the current reality of lying in a bed. So that's similar as in dreams, where we get caught up in scenarios without questioning them. We have the absence of insight. So these parasomnia episodes, even if you tell them during the episode you're having a parasomnia episode, the people will protest. They will get angry. They will say, no, I'm not. This is real. This is real. That's what happens. So they really are in denial about the hallucinatory nature of their experiences. And in a dream, most of the time, we don't realize we're dreaming, apart from lucid dreams, but that's a notable exception. So we have that. And people also call them dreams. So it makes sense to consider them dreams. There are two things that are different from ordinary dreams. It's the fact that they can interact with their environment and they can partially perceive the environment, which we don't do during normal dreams. Our dreams have nothing to do with our environment most of the time, although they can sometimes be influenced. And in parasomnia episodes, there is a relation, so they're partially connected to a certain degree. And then another interesting thing is that the themes of the dreams associated with parasomnia episodes are very similar one to another. So many patients tell me exactly the same stories. There seems to be a stereotyped content about the impending dangers, insects in the bed. I know that when they tell me about the insects in the bed, it's probably a non-REM parasomnia. It's so typical that actually within patients, but also between patients, they tell very often, or at least they remember the same dreams. So that's a bit different from normal dreams. And also what we've seen with the studies, that the no experience episode appeared to differ from the dream episodes, just like during normal sleep, the dreaming differs from the non-dreaming. So at least in terms of brain activity, they appear to share similar signatures. We don't still understand fully what these signatures represent actually, but there seems to be a parallel there. Now, if we look at also the content of the dreams, are more similar to the non-REM sleep dreams on average. So we have REM sleep, where the brain is very active, where the eyes move under closed eyelids, and that is very prominent in the morning. And most dreams we remember are actually from that stage normally. Those are the story-like dreams with very, very vivid images. The non-REM dreams can be like that, but on average, they're shorter, they're more conceptual, they're more closer to reality. And that's what the parasomnia dreams are also more similar to. But it makes sense because the parasomnia episodes occur in non-REM sleep. But I would say one of the conclusions I have is that I think it's a good model to study dreaming because we can see actually what they're dreaming about in real time when they have these conscious experiences.
Are you waking them up after their experience, or do they spontaneously wake up, or at what point are they actually reporting their dreams?
Some patients actually gave us a signal when they were back. When they realized they were having an episode, one clapped in his hands and told us, okay, it's over. I'm realizing I just had an episode. I'm ready to talk about it. But that was the exception. Most of the time, they would have the episode and then they would go back into a sleeping position again. And that's when we came in and, we interviewed them and asked them about their experiences. But it's usually a matter of a few seconds after the episodes.
You did wake them up at that point?
Yes, that we interviewed them. In some cases, they were gradually had returned to a normal waking level. And in some cases, they were in this hybrid state, and then we brought them to full consciousness.
And would they then go back to sleep and possibly have another episode?
Yes.
Okay, so I think you've convinced me that these are dreams and that they fit all the criterion for dreams. But what you didn't talk about is actually the EEG evidence for this. So I know that you have, prior studies where you looked at what the brain is doing during dreaming, and there are signatures for that as well. And I assume that the activity was quite similar during these states as what you've seen previously. Is that right?
Exactly. So I did a previous study with my colleagues at the University of Wisconsin where we woke up normal sleepers during their sleep and asked them what they were experiencing. And we found that some instances they could tell us, just like the sleepwalkers, what they were experiencing. In other cases, they said there was nothing, I had no experience. And when we compared these instances, regardless of whether it was REM sleep or non-REM sleep, we saw a greater EEG activation, so a greater activation of the cortex probably in posterior brain regions when they were dreaming, as opposed to when they were not having any experiences. And that's exactly what we found also in the sleepwalkers.
And so is that the beta frequency again?
Yes, it's the low frequencies that were lower and the high frequencies that were higher. And the high frequencies, yes, in the dream study it was the gamma, but also the beta. And in this case, we could only go up to beta because the gamma was too artifactual.
Yeah. But so the point is that the kind of EEG signature was roughly, it matched what you would expect for dreaming based on that prior study.
Yes.
Yeah. It's so interesting. Were some of your participants children or were they all adults?
No, we only did this in adults, but it would be absolutely fascinating to do this in children. Already it's more frequent. And then there are some studies suggesting that children do not experience their episodes like adults. Children much more often say that they were not experiencing anything compared to adults. And many patients actually related, yes, when I was a child, I didn't remember anything or I think I didn't experience anything. And I only started to have the dreams with my episode much later when I was older. So that was a common thing the patients reported.
Why would that be?
Well, if we think that indeed the slow waves reflect processes that interfere with consciousness, we know that children have much bigger slow waves, so have more slow wave sleep. So I would expect that during episodes they would also have more slow waves, and possibly these processes interfere with the generation of the complex dream experiences.
Mm-hmm. So it kind of goes back to what we said about the troughs of the slow waves kind of taking bites out of that mentation. And when you say the generation of the dream experiences, so can I push you a little bit more on what might be happening there? So if you didn't have so many slow waves, how do you think those dream experiences are generated and also remembered? Because you have to not only experience them, but remember them when you're woken up, right?
Yes, so this is a big question. Obviously, we still don't know. Actually, what we know is that the dream experiences, they seem to activate similar areas than our waking experiences. When we see something in a dream, we see an activation in the visual areas, just like we see it during wakefulness. We saw, for instance, that when you dream of a face, then the face area in the brain, called the face fusiform area that recognize faces, is more active as opposed to when you don't see a face, similar to wakefulness actually. So it's as if we had seen that the screen on which the dream movie is projected is the same. So we have a screen, same as in wakefulness. But in wakefulness, how do the images get there? Through the senses. We see a face, so it goes through the eyes. During dreams, the senses are more or less shut, so the face must come from somewhere else. And where this happens in the brain, that's a big question. We still don't know how this relates to memory processes that might go on in the brain. The study that we did in sleepwalkers, well, at least some experiences appear to be induced by the sound, because it was a confabulation around an arousing stimulus that then unfolded into a longer dream. So the question we're looking at in my lab now is, what role do arousal systems play in the generation of dreams? But this question is still open, and it's the big question, I think.
Yeah, I think it's a big question, and I'm not sure if I actually understood that answer. So, I mean, the role of the arousal systems as in, okay, so the sound triggers something, and then you have some kind of a perception, whether it's auditory or the sound just triggered something, and then you have a visual perception, as it sounds like a lot of people did. And then that's in the cortex, but that is getting then saved into the hippocampus maybe as an episode? Or, I mean, do you think about those kind of dynamics?
Yes, that's even more complex, but yeah, I don't know how it plays out then at the level of the hippocampus. But I think it is conceivable that arousal systems might play a role even in the generation of dreams. So arousal system is in the sense of activations in the brainstem. And one of the original hypotheses on dreaming by Alan Hobson's, that is a bit outdated now, but I don't think the role of a arousal system should be totally excluded in the generation of dreams. Then how it relates to the hippocampus, I don't know. But what we did in the sleepwalking case is we induced arousing experiences that were secondarily enriched as a dream, probably. That's at least what the description suggested. And we know that arousal systems are active during sleep, spontaneously, even without us playing any sounds. And do these almost periodic activations will play a role in the generation of dreams? We still don't know. It might just help to remember a dream, for instance. There are many possibilities.
Yeah, so it's a tricky question.
It's a tricky question. We have by no means proven anything. It just opens, I think, even more questions.
All of what you've said is so fascinating. I just ask you two other quick things. So we haven't talked really about REM sleep. Could you maybe just tell us a little bit about the REM sleep parasomnias?
So parasomnias can occur either in non-REM sleep, like arousal disorders, sleepwalking, sleep terrors, confusion arousals. Those are the non-REM parasomnias. And then there are also REM sleep parasomnias. Perhaps the most known is called a rapid eye movement sleep behavior disorder, also RBD. RBD is a condition that occurs, as the name says, during REM sleep. Normally during REM sleep, we have very low muscle activity. Probably this relates into a functional muscle paralysis. And the general idea is that this prevents us from acting out our dreams. And there are conditions where this muscle paralysis is lost and where people actually have excessive muscle activity and even very complex behaviors. And often if you wake up these patients and ask them what they were experiencing, they will tell you very specific dreams with goal-directed actions that match the behaviors that you see. Now, this is a different type of parasomnia because it occurs in REM sleep, so more frequent in the second part of the night. And also the age group and the cause of this parasomnia is very different. So while non-REM parasomnias, or the confusion arousals, occur very frequently in childhood and then really diminish in adulthood, the REM sleep parasomnia, so the RBD, is more frequent in people after 50 and can also be the first sign of some neurodegenerative disorders, like for instance Parkinson's disorder or other disorders in this group called synucleinopathies. So it can be the first sign even before other signs of the degenerative orders appears. They can already have the sleep disorder, so the RBD, which is an important sign for clinicians actually.
And that's the most common REM parasomnia, is it?
Yeah, some people also count nightmares as a REM parasomnia, but that's again different.
Yeah, I have a question about nightmares. So, there is this idea that in REM sleep you can't have bodily responses, like autonomic responses, we call them. So, increases in your pulse rate, sweating of your palms, things like that, because the balance of neurotransmitters means that those systems are kind of offline. But I believe that when people have nightmares, they do have those responses. Can you comment on that at all?
Yes, so there are actually very few nightmares recorded in the lab. So I think the question is still open. And I also think that within non-REM sleep, heart rate can be very variable. And yes, in humans, the sweating response is clearly reduced, although not completely abolished, like in animals. But there can be some variation. But there are also cases described where the mental content, the nightmare, did not match the other measures like heart rate. So it's still an open question. I haven't seen a good study where a nightmare was actually captured in the sleep laboratory and these variables were studied at the moment where the nightmare has supposedly occurred.
Okay, so we don't know, basically. It's another thing that remains for us to study, which is great because there's plenty of work for us to do.
Yeah.
Okay, well, thank you so much. I mean, this has been fascinating and I've learned a lot.
Thank you for having me.
You've been listening to the Sleep Science Podcast with me, Penny Lewis, and our special guest, Dr. Francesca Siclari. For more information about the podcast, check out our website. And if you enjoy the show, please feel free to like us on Twitter. Now, from me and all my colleagues at the NAPS Lab in Cardiff, thanks for listening and sleep well.